So now it's time to process our IR spectra and do some peak searching and see what they look like. So I'm going to open up the spectra. Unfortunately, this thing always points to JOChem instead of JData, because that's where the configurations file is stored. So I always have to go multiple things deep to get to it. So here's the tryptamine spectrum, and I want to correct that baseline. So we're going to tell it where the baseline is. And that's good enough. We'll replace that spectrum. It's a nice sharp looking spectrum. I can move this with the T. I can move that tryptamine from ethanol label down here. And I can change my display limits. So instead of starting at 80, I'm going to start at 75. That way I'll be able to see my peaks when they're labeled. And if I want, I can actually lower that a little bit so we can see that baseline more clearly. So that looks pretty sharp. So I'm going to save that. And I'm just going to call it. And again, I've got to go deep. Get back to my folder. And this is going to be corrected. I always like to keep the uncorrected sample so that if I want to go back, I can work with it. So now we're going to find peaks. We know that we care about that peak, so I'm going to set it below that threshold. Right. There are a lot of peaks. I'm going to go ahead and replace it anyway. Right. So some of these little peaks in the middle we probably don't really care about. So all these peaks here in this above 3,000, these four, I'm going to move those so they're kind of in one place. Those peaks are all sp2 carbon-hydrogen stretches. These peaks around 3344 and 3283, those are the amine NH stretches, and the fact that there are two of them is evidence that it's a primary amine, which is good because tryptamine is a primary amine, so that's kind of nice. And then these peaks here in this 29, 2800, those are the sp3 CH stretches. Right. And it's expanded over a little bit more of a region than you would normally expect it to be. This peak I don't care about, so I'm just going to delete that one. And that's probably because it's the fused aromatic rings. So I expect to see peaks for the ring breathing at around 1600. 1592 is the significant peak here, so we can delete these other two. We don't really need those. Right? Those are smaller. The peak we care most about here is this 1592. And then we expect there to be a peak at 1500, and there is. That 1500-1600 combination is usually pretty good evidence for aromatic rings. The benzene ring breathing, which we would expect to see. And then we've got some other peaks that are probably less well defined. 1434 is small. You can get rid of that one. This 1366, 1346, 1233. There's some carbon nitrogen stretching in there. So, and then these little tiny peaks at 1077. We can get rid of that. Right, this peak is obviously not significant. We just kind of clean things up a little bit. 897, right? That's a peak that's really tiny. There's no real need for seeing really tiny peaks. This one's probably not real either. So I want to label the biggest ones, but not label all these little tiny peaks in the middle. And then hopefully we'll be able to compare those to the literature. This is just a shoulder. Get rid of that one. 144. 534, 575 is obviously not significant. And then these peaks in the 400 range, we never care about those. Those are artifacts. So that's looking nice. Let's save that again. And now I'm ready to do my library search. So I'm going to check my library setup first and make sure it's pointing to the right libraries. Nicolay Condensed Phase Academic Sampler and the Georgia State Crime Lab. Those are the two that we usually use. And then I can search. And you can see that we don't get good matches. 36.65 to 2-ethylphenol is the best match we get, which almost certainly means that tryptamine's not in the library. I'm going to go ahead and print it anyway. And I'll print those on separate pages. And we'll call it tryptamine search results. At least with the printer, it will actually point to the right folder every time. So, and it's clearly not a very good match anyway, right? There's the phenol OH stretch. It's not there. This NH stretch is much more noticeable. I'm going to print this one while I'm printing. Corrected tryptamine spectrum. Oh, come on. Frickin' behave. There we go. And now I want to do that IR spectral interpretation to see if we can identify functional groups. And it thinks it's a para-substituted aromatic hydrocarbon. It really isn't, and unfortunately it's not identifying it as an amine, which it should. So we're going to go ahead and print that. It's actually more of an ortho-substituted aromatic hydrocarbon, but it is two fused rings. I'm going to save that, print that as tryptamine functional group results. And then I'm going to press on this little plus here. Oops, sorry, the glasses here. That's going to pull up the aromatic hydrocarbon group, but it will give you peaks for both ortho, meta, and para. So I can print this guy. And I'll include that in the printout. Tryptamine IR interpretation results. So you'll be able to use that to reach some conclusions. So that's tryptamine. Now we just need to do the same for the others. The cinnamic acid, so baseline correction. Carboxylic acids are always messy on the IR because the OH stretch really expands over a large portion of the whole spectrum. So we kind of expect to get a mess. Right, this huge region, right, that's the OH stretch and the CH stretch all overlapping. So now I want to change the display limits again like I did before. Instead of making it 78, I'm going to make it 72. Keep things on scale so we can see all the peaks. I'm going to move that down a little bit, and then I'm going to use the T to get this label out of the way. Somewhere where it's not going to get in the way. And I'm going to save that. Let's put it corrected in there. And I don't really need the from 4:1 aqueous ethanol part. Get rid of that. And now I want to label peaks. So I'm going to find peaks. I do want this. I'm going to put it just below that. And we'll replace that. Kind of curious as to what those are, so I'm going to use the T to label those. And by holding the shift key down, I can make sure it finds the center of the peak. So we've just got really a broad blob all the way from about 2100 all the way out to about 3100, which is pretty common. And now I can just move these guys. Right, so you can see that it's pretty messy. It's going to be a little hard to determine what's going on. We'd expect to see 1500 and 1600 again. We have that 1495, and then there's 1577. That's probably the benzene ring breathing. We'd expect to see a trans-alkene. That's probably that 1671. Probably the alkene CH stretch. And then we got a lot of these little peaks, which we can get out of here. There's some CO stretches in here. But it's messy. It wasn't the best pellet either, so. Some of these peaks in here are the monosubstituted benzene region. Monosubstituted benzene usually has two peaks in that kind of 700-ish region, so the 711 and the 769 might be that monosubstituted benzene. Oops, didn't mean to delete that one. That's a sharp peak. And I missed. Gotta hold the shift key down so that it gets the center of the peak. So that's nice looking. We'll save that and print it. Corrected cinnamic acid. And I'm going to do a search. And it's a match, but only a 34.29% match to E-cinnamic acid, 97% pure, which means that that pellet was pretty poor. This is a Nugel mull, so those peaks in here are actually from the mineral oil that the thing was suspended in, and that's part of the reason why we're not getting such a great match. The Nicolay condensed phase academic sampler, almost all of those samples are run as Nugel mulls. So you don't expect to get a great match, but 34% is still not very good. And that's a function of the pellet being a little bit too thick, or maybe I put a little too much sample in there. It was light and fluffy, so I thought I'd need it. And IR Spectral Interpretation says no matches are found. So what I'm going to do at this point, because sometimes it works better to do that spectral interpretation on the raw data, is I'm going to open up the original spectrum, and I'm going to try that functional group interpretation on the original spectrum. So we have our original E-cinnamic acid. And this time it comes up as an aliphatic primary amide, which is interesting because it's not. But we'll go ahead and print that anyway. But I'm going to go ahead and print this aliphatic primary amide because it'll tell you that NH stretching, which is actually very common for an amine as well, and that will help you identify the amine data for the tryptamine. So now we just want to go and do the same for the vanillin. Behave. And my vanillin spectrum, I need to do the baseline correct first. Drill. We're going to move this down here. And then we're going to save it. Well, actually, first I'm going to move this a little bit. And I'm going to set my display limits. Instead of starting at 79, I'll start at about 73. That way my peak labels will be on scale. And fine peaks. Probably good enough. So let's see.